Welcome everyone. Myself Imran Laiq from MSc Part 1, Rule number 37. I'm going to present a presentation in inorganic chemistry under the title of Difference between Hemoglobin and Myoglobin, Cooperativity of Oxygen Bending and Hemoglobin and Hill Equation. This presentation including the following uh, uh, topics I will explain step by step. First of all, what's hemoglobin? Hemoglobin is abbreviated as Hb or Hgb, is the iron-containing oxygen transfer metalloprotein in the red blood cells of almost all vertebrates except the fish family. It gives red color to blood, and its job is to carry oxygen from the lungs to the body tissues and returns carbon dioxide from the tissues back to the lungs. Chemical structure of hemoglobin. We can see here the chemical structure of hemoglobin. The hemoglobin molecule has four globular protein subunits. Each subunit is composed of a protein chain tightly associated with a heme group. A heme group consists of an ion held in a heterocyclic ring known as a porphyrin. This porphyrin ring consists of four pyrrole molecules cyclically linked together with the iron bond in the center. And the iron, which is the site of oxygen binding, coordinates with the four nitrogen atoms in the center of the ring. We can see from the below, the iron is bound strongly, means covalently to the globular protein, where the nitrogen atoms of the imidazole ring of F8 histidine residue. Okay, next, what's the myoglobin? Myoglobin is a red protein containing heme which carries and stores oxygen in muscle cells. It is structurally similar to the subunit of hemoglobin. It functions as an oxygen strong unit, providing oxygen to the working muscles. A high concentration of myoglobin in muscle cells allows organisms to hold their breath for a longer period of time. For example, diving mammals such as whales have muscles with particularly high abundance of myoglobin. Uh, Here's the chemical structure of myoglobin. We can see myoglobin contains 154 amino acids. Myoglobin contains a porphyrin ring with an iron at the center. And a proximal histidine 93 group is attached directly to iron, and a distal histidine 64 group is near the opposite face, and it is not bonded to the iron, but it's available to interact with the substrate oxygen. This is interaction encourages the bending of oxygen but not carbon monoxide. The bending of oxygen causes a substantial structure change at the iron center, which shrinks the radius and moves into the central of in-4 pocket. Difference in between hemoglobin and myoglobin. Hemoglobin is called as tetrameric hemoprotein, while myoglobin is called monomeric protein. Hemoglobin is found systematically all over the body, while myoglobin is found in muscles tissues only. Hemoglobin is made of protein and protein group and is well known for carrying oxygen pigment. And myoglobin works for muscle cells only by receiving oxygen from the RBC and further carry it to mitochondrial organelle of muscle cells. You can see here the difference between hemoglobin and myoglobin in this figure. Okay, the next one is Hill equation. The Hill equation was formulated by Archibald Hill in 1910 to describe the sigmoidal oxygen bending curve of hemoglobin. The Hill equation is useful for determining the degree of cooperativity of the ligands binding to the enzyme or receptor. Uh, the Hill equation is commonly expressed in the following ways. You can see here the Hill equation. Here is the uh, uh, plot of Hill equation. You can see here how to plot a graph for the Hill equation for the hemoglobin and myoglobin. Okay, next, what's cooperative bending? When an oxygen atom bends to one of the hemoglobin's four bending sites, the efficiency of oxygen of the three remaining available bending sites increases. Like, for example, oxygen is more likely to bend to a hemoglobin bound to one oxygen than to an unbound hemoglobin. This is referred to as cooperative bending. Cooperativity can be positive or negative. Christian Bohr and the concept of cooperative bending. In 1904, Christian Bohr studied hemoglobin bending to oxygen under different conditions. Uh, he indicates that the more oxygen is bound to hemoglobin is easier for more oxygen to bind until all binding sites are saturated. In addition, Bohr noticed that increasing of carbon monoxide pressure shifted this curve to the ring. You can see here this is the equation of uh, Kirsten Bohr for the concept of cooperative bending. Okay, next is the difference in a hemoglobin and myoglobin during cooperativity bending. Here we can see this curve shows difference in hemoglobin and myoglobin during cooperativity bending. We can see myoglobin made a hyperbolic curve, but hemoglobin made sigmoid curve. And the y-axis is the uh, uh, fractional substitution, and the x-axis is the pressure of oxygen. And here is the short comparison between hemoglobin and myoglobin. Hemoglobin is oxygen carrier, but myoglobin stores oxygen. Hemoglobin is present in RBC, but myoglobin is present in muscles and bone marrow. Hemoglobin is consists of four polypeptide, while myoglobin is consists of single polypeptide chain. And hemoglobin has the molecular weight of 4500, where myoglobin has the molecular weight of 1600. And hemoglobin shows Bohr effects, where myoglobin doesn't show Bohr effects, and hemoglobin shows sigmoid curve, like I explained before, but myoglobin doesn't show sigmoid curve, it shows hyperbolic curve. Uh, and these are the references from which I have prepared this presentation. Finally, I'm thankful from all teaching staffs of chemistry department which helped me in completing my presentation work. And especially thanks from Dr. Bevija Dev sir for guiding me in organizing this project assignment. Wish you all the best in your academic career. Thank you so much.